Hello, my Osage Trail scientist, and let's talk a little about questions. So, as a scientist, we ask questions. That's what we do. We want to know how the world works. So, I want to know, why is it that my dog pants? Why is it that when I cook something too high, it burns? Why did my water evaporate out of my cup overnight? I want to know these things. And to find out these things, we ask questions. So, questions are going to be a very important part of our study this year as we look at different topics in science. Now, before we get started, let's talk about a couple vocabulary terms. Gotta love the vocab, but it is important to know the terms. So, looking at a couple of these terms, and you will need to know these, we have two different ones. We have quantitative and we have qualitative. So, quantitative, if you just think about quantity, numbers, how much of something do I have? Do I have 5 apples? Do I have 7 dogs? That would be quantitative, the number of something. Whereas qualitative, if you just think quality, it's the quality of something. This is the description, the color, the taste, the smell, could even be opinions. So, the quality of something. So, quantitative, the number, qualitative, the description. Easy way to keep those two separate. And again, if you want to pause the video and write these definitions down, go for it. But we're going to go ahead and move on. So now, like I said, we like to ask questions. Scientists love questions. So we want to know, for example, why is that ant building that anthill? What's going on there? We like to watch it and see what's going on. Maybe pouring baking soda and vinegar together. What's the deal? Why is it fuzzing up? Why is it fizzing up all over the place? Or, maybe listening to a robin in the morning. Why does the robin sing like that? And these are the kind of questions that we kind of ask ourselves. But just asking, why does the ant build the anthill? That may not get to the key issue there. So we want to ask deeper questions. So we like to ask what are called scientific questions because what we want to know is we want to know about a phenomenon. Now, a phenomenon is just an event, just something that happens. So, the ant building an anthill, or better yet, a better one would be, something like watching water evaporate, lightning striking and causing a fire. I'm seeing these things and I want to know what's the deal. I want to better understand what's going on in my environment. So we ask scientific questions. Now, scientific questions, typically have two parts. They're a what if. So when we look at a scientific question, what we're going to do is we're going to change one item and we're going to see the effect that that change has on another item. And you notice here that we can record that change in quantitative or qualitative. So we can record it either way we want. It can be quantifiable or qualifiable. But we want to change one thing to see what happens. So when we change that one thing to see what the effect on another thing is, that's when we really start to get to the center. That's when we start to see what's going on. So let's look at some examples here. So going back to the anthill. So looking at our anthill here. So what kind of scientific questions could we ask? Originally we said, why does the ant build the anthill? But that's not something we can really research per se. We can't dive in and look at it. I mean, there's a lot of questions around that. Like, for example, who builds bigger anthills? Red ants or black ants? What about the ants that dig into wood? They don't build anthills like carpenter ants. They dig into wood. So in that case, well, who builds more extensive tunnels or bigger tunnels? Will a red ant or a carpenter ant? Which one builds more extensive tunnels or bigger tunnels? These are the kind of questions that get us thinking. Or if I pour water on an anthill, how long before they rebuild it? For example, when it rains, how long before they rebuild their anthill? So we change from the dry anthill, we add water, and then we see we see how long that takes them to rebuild. So we're changing the amount of moisture, destroying it, and seeing what happens. But these are the kind of things that we think about when we look at anthills. So it's more than just observing and looking at the anthill. It's asking those what if. What if I change this? What's going to happen with that? Let's take the baking soda and vinegar. So with baking soda and vinegar, pour them together. What's going to happen? It may fizz. Okay. So if it fizzes, great. But scientifically, what if I say, so what if I add 1 part baking soda and 2 parts vinegar? Will it be more fizz or less fizz? What if I do equal parts? What if I do more vinegar than baking soda or more baking soda than vinegar? Changing up those variables, changing up those different amounts, seeing what happens. So again, thinking more than just what happens. Thinking more than just, hey, it fizzes. But let's go deeper into that with our questions. The robin even. Looking at our example of the robin. What are some scientific questions we can ask here? So the robin calls in the morning. Yeah, it's pretty. But I mean, really, is there any questions we can ask there? Well, yeah. Does the robin's call sound different at sunrise compared to noon? So the variable, what we're changing there is the time of day. Same bird. Does the call sound different in the morning and at noon? If the robin gets scared, does it make a different call? If the robin is hunting a bird or hunting a worm, robins really don't hunt birds. If it's hunting a worm, is there a call there? So again, we're changing the behavior from just the robin singing in the morning. We're introducing the change of the worm and seeing what that worm change does to the call. But again, thinking along those lines with those questions. So let's look at some different testable questions that we have. So looking at these 4 questions, let's identify which one is testable and which ones are not. So the first one, what makes something sink or float? Well, I mean, are we changing anything? Are we modifying one thing to see its effect on another thing? Not really. That first question is more just informational. It's not really a testable question or a scientific question. So in that case, then, we're going to say that one is untestable. I mean, it's an interesting question. Number 2, what does changing the shape of a rocket's fin change its flight? Or how does changing the shape of a rocket's fin change its flight? If we make the fin big, what does that do? If we make it narrow, what does that do? If we make it look more rounded, maybe facing it forward, what does that do? So how changing that shape, how does that affect it? Well, are we changing something? Yes, we're changing the fins on the rocket. And we're tracking what that does to the rocket. So in that case, number 2 would be testable. Number 3, what happens when water expands as it freezes. Yeah. I mean, what are we changing? Well, we are changing the liquid water into a solid. So we are changing that. But we're not testing anything. We're just, again, asking an interesting question. I mean, it is an interesting question, one that we may want to refine a little bit to get a testable question. But again, not a testable. We can't really test anything there. Now, number 4, what conditions keep bread mold from growing on bread? Well, I mean, that one could be testable, but we may want to, again, maybe refine it a little bit. So it would be classified as testable because we are going to change the conditions and determine how that affects bread mold. So maybe put the bread in a Ziploc bag, put the bread on the counter, put the bread in the fridge, put the bread in the microwave. I don't know. See what happens. So put the bread in different places and just see. So that one would be testable. So in the end, questions 2 and 4, testable. Questions 1 and 3 are not. So we're going to look at this next week. We're going to take a look at a little experiment trying to identify some different items that are in a box, and you'll have an opportunity to write some testable or scientific questions about that. So what can we do to the box to identify what's inside? And you guys you'll see more about that next week. So we'll start that on next week. But for this weekend, think about some testable questions that you can come up with just for fun. And again, we'll talk more about this on Monday and Tuesday.